Hey, it's lesson 2.7. Absolute value functions and graphs. Yeah. Alright. Okay, so we talked about absolute value of x being the distance from 0. So the absolute value of f of x gives the distance from the line y equals 0 for each value of f of x. So y equals 0 would be that would be the horizontal x-axis. Simplest example of an absolute value function is f of x equals absolute value of x. The graph of the absolute value of linear functions in two variables is v-shaped, and it's symmetric about a vertical line that goes through the middle called the axis of symmetry. Such a graph has either a single maximum or a single minimum point called the vertex. Okay, so if we were to make a table of values, and if our x values went from -3 to 3, then our y values, or our f of x values, so y and f of x are the same thing. They're both the output of the function. It's just the absolute value of x. So 3, 2, 1, 0, 1, 2, 3. Now here's how you can break apart that function. You can say that f of x equals, so the absolute value of x equals x when x is 0 or positive. Right? So absolute value of 0 is 0, absolute value of 1 is 1, absolute value of 2 is 2. So if it's 0 or higher, then the absolute value of x is just x. But then, if x is less than 0, so if x is negative, then the absolute value equals the opposite of x. So -3, the opposite is 3. -2, the opposite is 2. -1, the opposite is 1. So the graph looks like this. When x is equal to 0 or greater, we get y equals x. Here's the line y equals x. When x is negative, we got the line y equals -x. And then right here at 0 is where they switch. So you got y equals -x here, y equals +x here. That's how the graph look. So, what is the graph of the absolute value function y equals the absolute value of x minus 4? And how is this graph different from, or how is it related to, the graph of the parent function f of x equals the absolute value of x? Alright, let's think. We should probably make a table of values and graph the function. So, if I pick -3, -1, 0, 1, and 3, and then I'm going to do the absolute value of -3 minus 4, and that's 3 minus 4, which is -1. And then I'm going to repeat that process for each one of these inputs, so I get this cool table of values. And then I'm going to plot those points, and then I can see how that V shape is going to go. So you use the location of the vertex to tell you where that function moved. The vertex of f of x equals absolute value of x is at 0, 0. So here's your absolute value of x function, the parent function. So what happened to this member of the family? It was translated down 4 units. So if we do -4 at the end, that's a translation down of 2 units. Cool. I mean 4. Subtract 4 goes down 4. That's what I said. It's not like there's a video of me saying it wrong. Okay, so what is the graph of the function y equals absolute value of x plus 2? And how is this different from the parent function? Well, we can make one of them cool tables, and we can do x, y equals absolute value of x plus 2. So we got -3, -1, 0, 1, and 3. So then we would get y equals the absolute value of -3 plus 2. Absolute value of -3 is 3, and 3 plus 2 is 5. So here's our point, -3, 5. Okay, when x is -1, y equals the absolute value of -1 plus 2. Absolute value of -1 is 1, so 1 plus 2 is 3. So we got -1, 3. When x is 0, y equals the absolute value of 0 plus 2. The absolute value of 0 is 0. So we get this point 0, 2. When x equals 1, absolute value of 1 plus 2 is 3. So we get the point 1, 3. 1, 3. And when x equals 3, its absolute value of 3 plus 2, absolute value of 3 is 3. 3 plus 2 is 5. So we get the point 3, 5. So basically we get the same V shape, but we just have the vertex. Whoa. It's kind of hard to draw with this thing. Ah, so close. So close. Ah! There we go. And now you know why I usually just have lines drawn in my PowerPoint. But anyway, how is it different? It is translated up. Now I can't write words either. It's translated up 2 units. So, if we look at B, do transformations of the form y equals x plus k affect the axis of symmetry? Nope. It doesn't move it sideways at all. It only moves it up or down. So the axis of symmetry is always going to be x equals 0. Cool. Okay, so take some notes here. Family of absolute value functions. The parent function is y equals absolute value of x. So for a vertical translation, translation up k units is absolute value of x plus k. Or down k units, u minus k. Vertical stretch, I mean these are all the same as with regular functions. It's just a times x. If a is bigger than 1, then it's a stretch. If a is between 0 and 1, it's a compression. Horizontal translation. Remember, this is the one where the sign is a little tricky. X minus h goes to the right, and x plus h goes to the left. Right, left. And then if you flip it in the x-axis, you're changing the sign of the output. If you're flipping in the y-axis, then you change the sign of the input. Okay, so which of the following is the graph of y equals x plus 2 plus 3? Well, let's see. The plus 3 is going to be in shift up 3 units. And the plus 2, remember, inside here has the opposite effect, so we're going to go left 2 units. So which one goes up 3? So we're starting from the origin. Up 3, left 2. Nope. Up 3, left 2. Nope. Up 3, left. Nope. Up 3, left 2. Yay! It was D all along. And if you like seeing things typed, there it is. Alright, so see if you got it. See if you got it. Pause, and then push play to see if you got it. Okay, so a minus 2 in by the x is going to be right 2 units. And plus 1 on the end is up 1 unit. So our new vertex is at the point 2, 1. And that's the graph of that function. Cool. So the right branch of the graph y equals absolute value of x has a slope of 1. Because remember, the right side is just y equals x. So that's the slope of 1. So the graph of y equals some number times the absolute value of x. This one has a slope of a. So the right side will have a slope of a, and the left side will have a slope of negative a. So let's take a look at what the heck. What is the graph of y equals 1/2 absolute value of x? It's a vertical compression because we're doing half of that. So our slope is going to be 1/2 on the right side. So it's going to be half as tall. So when we go over 1, we go up a half, which means when we go over 2, we just go up 1, over 4, up 2. You notice that on the right side, it's the line y equals 1/2 x. The slope intercept, the y-intercept is 0, and then 1/2 is up 1 over 2, up 1 over 2. And then the left side is y equals negative 1/2 x. Okay, so we would go, if we go up 1, we have to go backwards 2, up 1, backwards 2. So that if you were counting from left to right, you would go down 1 to the right 2, down 1 to the right 2. Okay, so see if you can figure out what the graphs of these bad boys are. Okay, so y equals 2 times the absolute value of x. So let's see. There's a couple ways we can think about this. We can say, all right, this is going to be twice as tall as the absolute value of x. So if my absolute value of x was going through here and here, then it would just be twice as tall. So over 1 up 1 would become over 1 up 2. Over 2 up 2 would be over 2 up 4. Another way to think about that is to say, is to just plug in some values. You can always make a table of values. So -2, -1, 0, 1, 2. Absolute value of -2 is 2. 2 times 2 is 4. Absolute value of -1 is 1. 1 times 2 is 2. Absolute value of 0 is 0. 0 times 2 is 0. Absolute value of 1 is 1. 1 times 2 is 2. Absolute value of 2 is 2. 2 times 2 is 4. So what we get is these points, 1, 2, -1, 2, 2, 4, -2, 4, 0, 0, and then we draw our V shape through there. So that's a vertical stretch by a factor of 2. So now for this one, I'll show you another way to look at it. You can say that the right side is going to be y equals -2/3 x. So that's when x is greater than or equal to 0. And then on the left side, when x is less than 0, y is going to be equal to the opposite of that. It's going to be 2/3 x. Okay, so what's that going to look like? -2/3 x, we're starting at 0, and -2/3 slope is down 2 over 3. Over here, a slope of 2/3 would be, if we were counting, normally you would say up 2 over 3, but over here on the right side is not when x is less than 0. So if we were counting from right to left, we would say down 2, back 3. Down 2, back 3. So now we're over here where x is less than 0. And so we can draw our lines through there. We got this upside down V. So the negative makes it go down, and the 2/3 squishes it down. Instead of going with a slope of -1 here, it's going slightly more shallow. Hand carts. That is your le secret phrase. Okay, so the general form of the absolute value equation. This one has the a part included, the h part included, and the k part included. So the stretch or compression factor is a, absolute value of a. And you can think about it, if a is negative, that's flipping it down. So negative a value means you're flipping your v down. The vertex is located at hk. And the axis of symmetry is the line x equals h. So, problem 4. Without graphing, what are the vertex and axis of symmetry of the graph of this? How is the parent function y equals absolute value of x transformed to get that? So, we should compare. What should we compare this to? Hey, what about this? Yes, we should compare it to that. So, if we compare y equals 3 times absolute value of x minus 2 plus 4 with the general form, we get a equals 3, h is 2, because it's x minus h, so x minus 2, and then plus 4, so k is 4. So the vertex is hk, so 2, 4 is the vertex. The axis of symmetry is x equals h, so that's x equals 2. So the parent function y equals absolute value of x, it's translated 2 units to the right, 4 units up, and vertically stretched by a factor of 3. So minus 2, that means 2 units to the right, plus 4 is up 4 units, times 3 is stretch, 3 times taller. So, what are the vertex and axis of symmetry of this? Go ahead and pause and see if you got it. So what are the vertex and axis of symmetry of this? Well, the vertex is, what do we got? We got A is negative 2. We got H is, so this is a minus H, so H is 1. And K is negative 3. So the vertex is HK, which is 1, negative 3. And the axis of symmetry is the line x equals 1. And how is this a transformation of the parent function? And you would say it is a translation 1 unit to the right, 3 units down, and a stretch, a vertical stretch by factor of 2, and the negative sign means that we're going to reflect across the x-axis, which actually we probably have to reflect first and then do the translations. All right, so there's that. What is the equation of this absolute value function? Well, first we need to identify the vertex. We go back 1 and up 1, 2, 3, 4. So the vertex is negative 1, 4. So h is negative 1 and k is 4. Now we need to figure out what a is. So what's the slope of the branch to the right? We go, where's the line cross another grid point? Boom, right there. So to get there, we go down 1 over 1, 2, 3. So our slope to the right is negative 1/3. So that means that a is negative 1/3. So now we just write the equation. And we're just going to substitute the values into y equals a. This is the general form. So y equals negative 1/3. And then when you do minus the negative 1 for h, that turns into the plus 1. And then plus k is plus 4. Okay, so pause and see if you can figure out the equation for this absolute value function. Alright, so first we need to identify the vertex. And we go over 1, 2, and down 1. So the vertex is 2, negative 1. So that means h is 2, k is negative 1. And then what is our slope on the right branch? It seems like we're crossing here, so we would go up 1 over 1, 2, 3, 4. So that's a slope of 1/4. So that means a equals 1/4. So now we just need to plug in to the general form. Y equals a times absolute value of x minus h plus k. So 1/4 times x minus 2 plus negative 1, which is minus 1. And that, my friends, is the equation for this absolute value function. Well, I hope you had as much fun as I did, but it's time to go. So work on this practice here, work on this formal write-up here, and I'll talk to you later. Bye-bye.